Hello, today we're going to look at solving a quadratic equation by factoring. The key idea here is that if a quadratic is not already in factored form, then to use the zero property, we must factor it first. So some of the methods that we have of solving quadratic equations, in other words, when we're solving them, we're looking for the x-intercepts, the roots, the solutions. And we can use several methods to do that. We can use just general factoring. We could use the quadratic formula. We could use completing the square. We could also use difference of squares. What we're going to focus on in this particular lesson is factoring and difference of squares. Now, when we talk about factoring, it could be greatest common factor. It could be factoring a trinomial. So I don't want you to get hung up on, one or the other. Just know that we're factoring. So let's go ahead and look at the first one we have here. And I do have a note for you. In order to do this, you must always make sure that the equation is set equal to 0. So for our first one, we've got solve for j. We've got 41j squared plus 43j equals 0. It's already set to 0, so what we're going to do is think about 41 and 43. Both of those are prime numbers, and we know that they're prime because only 1 times 41 gives you 41. Only 1 times 43 gives you 43, so they have no number greater than 1 in common. So to divide both by 1 won't do anything. So we're just going to leave 41 and 43 as is. However, they do have a j in common, so we're going to factor out the j. And when we do that, it's like dividing it out. So what we have left is 41j plus 43. We're going to set that equal to 0. Now when we do that, we're going to set j equal to 0, and then we're going to set 41j plus 43 equal to 0. And we're back to zero product property. Now, j equals 0, so we just have to solve this one. We want to eliminate the 43, so we're going to subtract 43 from both sides of the equation. That leaves us with 41j equals negative 43. I don't want 41j, I just want j, so I'm going to divide by 41 on both sides of the equation. And that leaves me with j is equal to negative 43 over 41 as well as 0. Let's go ahead and take a look at the second one. Now the first thing you want to do when you have a trinomial is you want to see if a greatest common factor will help you. So when we talk about greatest common factor, we're looking for the largest number that is divisible into all three coefficients evenly without leaving a remainder. And in this case, there is nothing that we can divide, greater than 1 of course, that would go into 3, 11, and 10. So we can't use a greatest common factor on this. So the first thing I want you to do, we're going to use what we call the Berry method. You're going to write the first term, and you're going to write the last term. Keep in mind to take the sign with it. Then you're going to multiply the first term and the third term. So in this case, 3 times positive 10 is positive 30. And we want the factors of 30 that add to 11. So again, we want the factors of 30 that add to 11. So I'm going to kind of write that really small here. Factor of 30 add to 11. So when I think of 30 and I want to think of the factors of 30, I could do 1 and 30, but that would equal 31 if I added them together. I could do 2 and 15, but that would equal 17 if I added them together. We could do 3 and 10, but that would equal 13 if we added them together. 4 doesn't go into 30 evenly, but 5 does. 5 and 6, and if we add those, oh, we get 11. So we want to use the factors of 5 and 6. Now, I could put them in this order. I could put plus 5n plus 6n, but that would leave me with some fractions, and I not that I don't like fractions, but if they're not necessary, then we don't want to create them. So what I'm going to do is I'm going to put the 6 with the 3, because I know 3 goes into 3 and it goes into 6, and I'm going to put the 5 with the 10. So I'm going to split this middle term, the 11m, into 5 and 6. So I've got plus 6m plus, because these are positive, 5m. That kind of looks all scrunched up together, but then we're going to group both terms, and I've got 3m squared plus 6m, and I'm going to use the greatest common factor for those. They have 3m in common, so that leaves me m plus 2. And you can check it. 3m times m gives you 3m squared. 3m times 2 gives you 6m. And because I'm running out of room, I'm going to take this one and put it on the next line. So 5m plus 10, they have a 5 in common, and 5 goes into 5m, m times. 5 goes into 10, 2 times. So these two factors have to be the same, and the factors on the outside, the greatest common factors, we're going to use those as one factor. So we end up with m plus 2 multiplied by 3m plus 5 equals 0. Now we set both equal to 0 and we solve. So m plus 2 equals 0. Subtract 2. Subtract 2. M is equal to negative 2. And then we've got 3m plus 5. Set that equal to 0. Subtract 5 from both sides of the equation. 3m is equal to negative 5. Divide by 3. Divide by 3. Therefore, m is equal to negative 5 thirds. I tried to make that fit. It didn't go so well. So m is negative 2 and m is negative 5 thirds. Now, our next one says solve for w. Now notice how these are different. This one has a plus sign, this one has a minus sign. This has variables that are common to each. This one does not. So notice here, it's a subtraction sign. The other word for subtraction is difference. Now think of this. Could I possibly take the square root of w squared and the square root of 49 and come up with numbers that if I multiply them together, I get this result? Well, I certainly could. I know that the square root of w squared is w. And I also know the square root of 49 is plus or minus 7. So when we're talking about the difference of squares, it's really one of my favorites. I love to factor regardless, but this one just makes it so simple. We just write the first term, write the second term, write the first term, write the second term. So we write it twice. We put a plus in one and a minus in one. Now we're going to set that equal to 0. So we've got w plus 7 equals 0. W minus 7 equals 0. We're going to solve for w here. We subtract the 7 from both sides, so w is negative 7. We're going to add 7 on the other binomial, so w equals 7. So w equals both negative 7 and 7. So in difference of squares, your first thought should be, is what I have here the result of squaring a number? If it is, and there is a subtraction sign between them, definitely look at difference of squares. Let's go ahead and look at this last one, solve for view. Now, this is where my hint came in. Make sure that the equation is set equal to 0. This is not set equal to 0. So what I'm going to do is I'm going to add 12u squared to both sides of the equation so that I can get it set equal to 0. So I've got 12u squared minus 363 equals 0. Now, my next thought is, 12 is not the result of a number multiplied by itself. Because if I think about it, the closest I can come is either 3 times 3, which is 9, or 4 times 4, which is 16. So this is not the difference of squares, at least not yet. So the next thought is, can I apply greatest common factor? So I'm thinking, does 12 go into 363? Let's think about that. Well, 12 goes into 36, but doesn't go into 3. And what I'm doing is taking 12, seeing if it goes into 36, and it goes 3 times, but then I'm left with a 3. So that doesn't work. Well, then the next thought is there a number that I can divide into 12 and 363 that would leave me with a perfect square? And I'm thinking here, the factors of 12 are 1, 2, 3, 4, 6, and 12. Well, we already tried 12, that didn't work. 2 doesn't work because 363 doesn't end in a 2. 6 would work for this one, but not work for 363. So all we have left is 4. Let's see. So 4, we divide 4 into 12, we get u squared. But 4 into 363, that doesn't work because that gives us 990 something. No. So let's try 3. So if I divide 3 into 12, that leaves me with 4u squared. And if I divide 3 into 361, that leaves me with 121. 4 is a perfect square, and 121 is also a perfect square. So let's divide everything by 3. So 3 divided into 12u squared leaves me 4u squared. 3 divided into 363 leaves me 121. So we've got 3, and the square root of 4u squared would just be 2u. The square root of 121 would be 11. So we got 2u 11. Hold that equals 0. We put a plus in one, a minus in the other. Now we have to set all of these equal to 0. Well, 3 will never equal 0, so that solution does not work at all. But the other two, we've got 2u equal, no, I'm sorry, 2u plus 11 equals 0. And then 2u, minus 11 equals 0. And now we can solve. Subtract 11. 2u is equal to negative 11. Divide by 2 on both sides. Therefore, u is equal to negative 11 over 2. Here we're going to add 11 to both sides of the equation. 2u is equal to 11. Divide by 2 on both sides. U is equal to 11 halves. So we finally made it. Let me scoot this paper over so you can see. So sometimes it's not as straightforward as we'd like it to be, but it doesn't mean that it's not doable. So I've got your turn down here. Why don't you go ahead and try that and then come on back. Alright, so I've gone ahead and put the answers down for your turn. Please forgive this line right here. I wrote something and it didn't make sense, so I just made a squiggly line through it. Your answers are boxed here. And hopefully you got the right answers. If you didn't and you still need more clarification, just let me know. Have a good one.